Witness colossal crawler cranes shaping mega projects, then explore ingenious logistics moving extraordinary, oversized cargo across impossible distances worldwide with precision. Within a 24-hour work window, TNT Crane and Rigging executed a highly coordinated rail bridge replacement that demanded precision, speed, and heavy lift expertise. The operation began with the removal of the old bridge, which was carefully dismantled into 5 sections. Each segment was lifted in sequence, with the largest section weighing 270,000 pounds, requiring controlled rigging and exact crane positioning to clear the rail corridor safely. Once the site was prepared, attention shifted to installing the new structure. The centerpiece of the operation was the main bridge section, with a gross load weight of 1,001,000 pounds. Due to the extreme weight, a team lift was essential. TNT deployed 2 powerful crawler cranes, a DMAG640 and a Mammoet 18,000, working in perfect synchronization. The DMAG640 operated in an SSL configuration with a 157-foot main boom, supported by 396,000 pounds of superstructure, a 132,000-pound car body, and 110 200 pounds of superlift counterweight. During the lift, the crane performed a pick-and-carry maneuver, walking with the load to maintain a safe operating radius. Alongside it, the Mammoet 18,000 used a 160-foot main boom, backed by 520,000 pounds of superstructure and 320,000 pounds of car body counterweight, ensuring stability throughout the lift. After the main span was set, 4 additional bridge sections were installed, each weighing 245,000 pounds. Through precise planning and flawless execution, the new rail bridge was fully installed and operational within the tight deadline. TNT Crane and Rigging carries out a highly controlled heavy lifting operation using a 500-ton gantry crane system to handle a massive ship propulsion unit. The process begins with precise positioning of the gantry structure over the load, ensuring the ground is level and the crane legs are securely stabilized. Rigging crews carefully attach heavy-duty slings and lifting points to the propulsion unit, which weighs approximately 400,000 pounds and measures 24 feet tall, 14 feet wide, and 29 feet long. Once all safety checks are completed, the gantry system is slowly activated. The load is lifted evenly from the ground, with operators continuously monitoring balance, load distribution, and clearance. The propulsion unit rises steadily, demonstrating the gantry crane's capacity to handle extreme weights with accuracy and control. Throughout the lift, communication between crane operators and ground crews remains constant to maintain safety. After reaching the required height, the unit is carefully maneuvered and aligned for loading. It is then lowered onto the transport system with precision. Once secured, the propulsion unit is confirmed as safely loaded and prepared for transport to the dock, where it will later be moved to its final destination. At the Mammoet yard near Westorp in the Netherlands, a new era of heavy lifting is taking shape with the construction of Mammoet's new generation heavy lift cranes. These cranes represent a remarkable achievement in engineering, reflecting years of development, innovation, and ambition by one of the world's leading heavy lift specialists. Visitors arriving on site are immediately struck by the scale of the operation, where massive crane components dominate the landscape and demonstrate capabilities far beyond conventional lifting equipment. The new generation cranes are being built to meet the growing demands of global infrastructure, energy, and industrial projects. Designed for worldwide deployment, these cranes are destined for challenging locations, such as Brazil, Texas, and many other regions across the globe. Their development has taken approximately 3 years, highlighting the level of precision, testing, and expertise required to bring such advanced lifting systems into operation. What makes these cranes stand out is the combination of extremely high lifting capacity, long reach, and exceptional operational flexibility. Safety has been a central focus throughout the design process, ensuring that these cranes can perform complex lifts reliably, even in the most demanding environments. Despite their enormous size, the cranes are engineered for efficient transport and rapid assembly, allowing Mammoet to mobilize heavy lifting solutions anywhere in the world within a short time frame. For a Dutch family-owned company, the scale of this achievement is extraordinary. Engineers, technicians, and specialists from different countries work together on site, underlining Mammoet's international character. With more than 3,800 employees and around 60 offices worldwide, Mammoet continues to set industry standards in engineered heavy lifting and transport. In short, Mammoet's new generation heavy lift cranes embody vision, craftsmanship, and global ambition, redefining what is possible in modern heavy lifting. The Grove GMK640 Mega Wing Lift represents a major advancement in heavy mobile crane performance, combining power, flexibility, and efficiency in a compact design. The Mega Wing Lift is a self-rigging attachment, allowing the crane to install the system quickly without external assistance. With a total transport width of just 3 meters and a weight of 11 tons, it is specifically designed for easy transport on a 2.55-meter trailer, making logistics simple and cost-effective. One of its key advantages is the fast setup process. The Mega Wing Lift can be fully installed with only one lift in less than 20 minutes, significantly reducing rigging time on site. Installation is straightforward, thanks to hydraulic pins and an integrated rigging system located directly on the carrier deck within the wing arms, ensuring safety and precision during assembly. Flexibility is another standout feature. The Mega Wing Lift can be rigged 360 degrees, allowing operators to adapt quickly to different lifting conditions and job site constraints. Most importantly, the system delivers exceptional lifting performance. When installed, it increases the crane's load chart from 38 tons to 64 tons at a 60-meter boom, providing a substantial boost in lifting capacity. Compact, easy to install, and extremely powerful, the Grove GMK640 Mega Wing Lift sets a new standard in mobile crane efficiency. The Grove GRT8100 is a modern rough-terrain crane engineered to deliver outstanding maneuverability, lifting performance, and operational efficiency across demanding job site conditions. Designed with advanced mobility systems and operator-focused features, this crane sets a high standard in its class for versatility and reliability. One of the key strengths of the GRT8100 is its class-leading maneuverability. The crane is equipped with 4 steering modes: front steering, rear steering, crab steering, and coordinated steering, allowing it to adapt easily to confined or complex work sites. With 6 forward and 6 reverse speeds, operators benefit from precise speed control for smooth positioning. The 4x4 transmission ensures efficient power delivery over rough terrain, while dry disc brakes provide quick and reliable stopping power. In addition, the articulated rear axle enhances mobility by maintaining tire contact on uneven surfaces, improving stability and traction. Transport and setup are significantly simplified on the GRT8100. Lightweight aluminum outrigger floats are designed for quick and easy installation, reducing setup time without compromising strength. The crane features 3-position outrigger jacks retracted at 3, 150 mm, mid-extend at 5, 233 mm, and full extend at 7, 316 mm, offering maximum lifting stability in a variety of configurations. An available outrigger monitoring system ensures secure lifting by confirming proper outrigger deployment. Inverted jack cylinders protect the cylinder rods from dirt and debris, increasing durability in harsh environments. The hydraulically removable counterweight further improves setup efficiency, with a standard 979 kg option and heavier optional configurations available for increased lifting capacity. Superior operation is achieved through Grove's advanced crane control system, which provides user-friendly, integrated machine control. A capacity limiter, combined with a working range limiter, enhances lifting safety by preventing overloads. Operator access is improved through redesigned cab entry and well-placed handrails, allowing easier entry and exit. Inside the cab, improved air conditioning comes standard to enhance comfort during long working hours. The full vision cab, capable of a 20-degree tilt, significantly improves visibility, especially when working at high boom angles. Continuous 360-degree rotation allows flexible crane positioning, while the house lock pin and optional 360-degree pawl securely lock the superstructure to the carrier when required. A complete halogen lighting package, including standard cab work lights, ensures safe operation in low-light conditions. The GRT8100 is equipped with a 47-meter megaform boom, featuring 5 full-power sections that deliver excellent reach and lifting performance. With a maximum load radius of 44.2 meters, the boom offers multiple extension options to suit various lifting tasks. Heavy tilt jib extensions provide offsets of 15 degrees, 35 degrees, and 55 degrees, while an optional hydraulic bifold jib offers 0 degrees, 20 degrees, and 40 degrees offsets for added flexibility. Strong load charts and class-leading capacity at multiple radii, combined with the best hoist line pull in its class, make the GRT8100 a powerful and dependable lifting solution. Finally, the crane's design emphasizes greater serviceability, enhanced maintenance access, a remote-mounted fuel separator, lockable battery disconnect, and remote-mounted transmission dipstick all contribute to easier and safer servicing. Hydraulic fluid levels and temperatures can be conveniently checked through the crane control system, minimizing downtime and maximizing productivity on the job site. The process of using the Liebherr LTM1750-9.1 to move and lower a large power transformer onto a transport vehicle was carried out with very high precision and safety. First, the LTM1750-9.1 crane was deployed at the construction site on a solidly reinforced foundation. With its 9-axis boom configuration and full extension outriggers, the crane quickly achieved the necessary stability for the super heavy lifting task. Counterweights were installed according to the calculated lifting plan, ensuring optimal load-bearing capacity throughout the operation. After completing the preparation work, the crane began extending its 52-meter-long telescopic boom, adjusting the lifting angle to match the transformer's position. Thanks to its maximum lifting capacity of 800 to 900 tons, the LTM1750-9.1 easily met the lifting requirements of this very large piece of equipment. The cables and hooks are precisely attached to specialized lifting points on the transformer body, ensuring the load is evenly distributed. Next, the operator performs a slow test lift to check the stability and responsiveness of the load. When all parameters meet the requirements, the transformer is slowly and carefully lifted from the support platform. Throughout this process, the lifting speed is maintained at a low level to minimize vibration and protect the equipment's structure. Once the transformer has reached the required height, the crane begins to rotate its boom to move the load into the correct position on top of the specialized transport vehicle. Thanks to its large working radius of over 110 meters and precise control system, the load is perfectly aligned with the vehicle's floor. Finally, the transformer is gently lowered, placed in its designed position, and securely fixed, ready for transport. The entire process demonstrates that the LTM1750-9.1 is not only one of the world's most powerful telescopic cranes, but also the ideal solution for ultra-heavy industrial equipment lifting tasks requiring absolute precision and safety. The operation documents a complex transport and installation of bridge girders for a motorway bridge near Rheinfeld. The project is carried out by Eisel AG from Frankfurt am Main, represented on-site by Operations Manager Roger Schimmel. Due to their exceptional size, the bridge girders, each measuring 50 meters in length, could not be transported directly from the fabrication plant to the installation site. Instead, a temporary storage and assembly area was established close to the motorway. Individual girder sections were delivered separately, welded together on site, and fully assembled to their final length. Once completed, the girders were transported over the final few kilometers using self-propelled modular transporters. These specialized vehicles allowed precise maneuvering through narrow sections of the route, including challenging turning movements using a rotating axle configuration. 2 identical SPMT units were deployed, enabling the transport of 2 girders at a time. The transport took place at night under police escort, supported by BF-3 vehicles to manage traffic and ensure safety. The SPMTs hydraulic system allowed the transport height to be adjusted by up to 700 millimeters, making it possible to place the girders onto temporary supports on the motorway without using cranes. This process was repeated until all girders were staged on the closed section of the A1. During the following night, the motorway was fully closed, and the central barrier was removed. Two large mobile cranes then lifted the girders one by one from the SPMTs into their final position on the bridge structure. Careful planning, precise execution, and close coordination ensured that the entire transport and lifting operation was completed safely, undamaged, and within the scheduled time window. The dismantling of the tower crane begins with a carefully planned and sequential operation to ensure maximum safety and structural stability. First, attention is given to the counterweights, as they play a crucial role in balancing the crane. Using an auxiliary mobile crane, the counterweight blocks are individually unbolted, lifted, and lowered to the ground. Each lift is performed slowly and precisely to prevent sudden load shifts that could affect the crane's balance. Once the counterweights are fully removed, the dismantling team proceeds with the jib or main working arm of the tower crane. The jib is first secured with lifting slings attached to the mobile crane. After load transfer is confirmed, the connection pins between the jib and the slewing unit are carefully released. The jib is then lifted away in sections or as a single assembly, depending on its length and site constraints, and safely placed on the ground for disassembly and transport. Following the removal of the jib, the counterjib is dismantled. Similar to the previous steps, lifting slings are attached and the load is gradually transferred to the mobile crane. Bolts and structural connections are removed in a controlled manner. The counterjib is then lifted clear of the tower mast and lowered to the ground. Throughout the entire dismantling process, clear communication between operators, riggers, and supervisors ensures smooth coordination, maintaining safety and efficiency at every stage. An extraordinary heavy transport operation using multiple modular container vehicles connected together to carry an ultra-heavy load on a massive trailer system. Each unit is linked in perfect coordination, forming a single transport platform supported by an astonishing 472 tires. These multi-axle modular trailers are designed to distribute extreme weight evenly, allowing the convoy to move safely without damaging roads or bridges. Hydraulic suspension systems automatically adjust axle loads, keeping the cargo stable during slow and precise movement. The connected vehicles operate under centralized control, enabling synchronized steering so the entire transport can navigate tight corners and narrow routes. Such systems are commonly used for moving oversized industrial components like power plant equipment, refinery modules, or offshore structures. This operation highlights the incredible engineering behind modern heavy haulage, where teamwork between vehicles, advanced technology, and careful planning makes the transportation of seemingly impossible loads a reality. Complex heavy haulage operation carried out by Alilis, showcasing the careful transportation of an extremely heavy and oversized load through public roads. The cargo is mounted on a long modular platform trailer equipped with numerous axle lines, allowing the immense weight to be evenly distributed and safely supported throughout the journey. Hydraulic suspension systems continuously adjust axle heights, ensuring stability while navigating uneven road surfaces and tight curves. Multiple prime movers are connected to the trailer in a push-and-pull configuration, providing the precise traction and braking control required for such a demanding transport. Due to the size of the convoy, the operation proceeds at very low speed, with every movement carefully coordinated. Trained ground crew members in high-visibility protective clothing walk alongside the vehicle, giving hand signals and radio instructions to guide the drivers through narrow junctions and restricted turning radii. Traffic is temporarily stopped and controlled to create a safe corridor for the convoy, highlighting the importance of detailed route planning and cooperation with local authorities. As the transporter negotiates bends and road cambers, constant communication ensures that axle loads remain balanced and that no component exceeds its mechanical limits. This operation demonstrates Alilis' expertise in heavy haulage logistics, combining advanced transport technology, skilled personnel, and meticulous planning to move critical industrial equipment safely and efficiently to its destination. A special transport operation took place in Thonon on March 16, 2022, involving the movement of an impressive yacht named Dolce Vita. The yacht was transported from the port of Rive to Marseille, requiring a complex road journey through urban streets before reaching the main traffic routes. From the outset, the scale of the operation was clear. The yacht was placed on a specially designed multi-axle trailer, towed by a powerful heavy-duty tractor. Due to its enormous length, width, and height, the convoy moved at a very slow and carefully controlled pace. Escort vehicles led and followed the convoy, regulating traffic, ensuring security at intersections, and guaranteeing the safety of pedestrians and surrounding infrastructure. One of the most challenging moments of the transport occurred at the Place des Arts roundabout. This location presents severe space constraints, with sharp turns, curbs, traffic islands, and street obstructions, severely limiting vehicle maneuverability. Navigating the roundabout requires precise steering maneuvers, while the tow truck's hydraulic system and steering axles adjust in real time. The rear axles rotate independently, allowing the trailer to follow a complex trajectory to minimize the risk of collision. Throughout the process, ground crew members play a crucial role. Positioned at key points around the roundabout, they maintain constant communication with the driver, providing hand signals and verbal instructions. At times, progress nearly comes to a standstill, as adjustments are made centimeter by centimeter. Street signs and obstacles are closely monitored to avoid damaging both the yacht and the urban environment. The video clearly demonstrates the patience and coordination required for such an operation. Traffic was temporarily disrupted, and onlookers watched the convoy slowly navigate the roundabout after a few tense minutes. Once past this crucial point, the transport continued through the city under close supervision. Overall, this extraordinary convoy demonstrated the complexity of transporting oversized vessels through congested urban areas. It showcased advanced transport technology, masterful driving skills, and precise teamwork, all essential for successfully moving a luxury yacht like the Dolce Vita from the lakeside harbor to the open sea. An extraordinary transport operation was carried out in Aubigny-sur-Ner, where enormous industrial tanks were transported to the Boudagaz plant. Each tank weighed up to 350 tons, and was one of the most difficult goods to transport on public roads. To overcome this challenge, the convoy was divided into 3 separate transport groups, each consisting of a massive vehicle assembly 64 meters long, 5 meters wide, and 7 meters high. The most dramatic moment occurred when the convoy navigated a narrow bend in a densely populated residential area. The normally busy roads were temporarily transformed into areas requiring precise maneuvering. Buildings, sidewalks, and objects on the street allowed for almost no room for error. The drivers, supported by escort teams positioned at key points, advanced at an extremely slow speed, adjusting the steering angle centimeter by centimeter. The hydraulic steering axles on the modular trailer play a crucial role, allowing the rear wheels to rotate independently and follow the precise trajectory needed to navigate the curve. Meanwhile, observers constantly communicate with the driver, signaling the distance between the cargo and nearby obstacles. Any misstep could result in property damage or delay the entire operation. Local residents lined the streets, watching intently as the massive tanks slowly passed within meters of their homes. The scale of the convoy, combined with the careful and purposeful movement, transformed the transport into a public spectacle. Despite the complex maneuver, the operation proceeded smoothly, demonstrating a high level of planning, coordination, and technical expertise. Ultimately, successfully navigating the tight curve demonstrated the precision and professionalism required in specialized transport, proving that even the heaviest industrial equipment can be safely transported through urban environments when preparation and teamwork are perfectly executed. The careful relocation of Alberta Railway Museum's 460 steam locomotive, No. 1392, from Edmonton to Stettler, Alberta. This complex operation combines heavy-haul transport techniques with heritage preservation, preparing the historic locomotive for its appearance at the Rails and Tails Steam Festival, celebrating Canada's 150th anniversary. The operation begins with the locomotive positioned on a prepared section of track inside the museum grounds. Due to its significant weight and historic value, every step is planned in advance. Engineers and rigging specialists inspect the locomotive, identifying structural lifting points and ensuring that fragile components such as piping, valves, and fittings are protected before any movement takes place. A heavy-duty mobile crane is set up alongside a specialized low-bed transport trailer. This trailer is designed specifically for oversized railway equipment, offering a low deck height to reduce overall transport clearance and improve stability on the road. Rigging crews attach lifting slings and spreader beams to the locomotive, carefully balancing the load to avoid uneven stress during the lift. Once the crane begins lifting, the locomotive slowly rises from the rails. This stage requires precise coordination, with spotters guiding the crane operator and monitoring clearances from all sides. The locomotive is lifted just high enough to be moved laterally and aligned with the trailer. Controlled movements ensure the historic structure remains stable throughout the transfer. The locomotive is then gently lowered onto custom-built supports mounted on the trailer deck. These supports cradle the wheels and frame, distributing the weight evenly and preventing movement during transport. After the locomotive is correctly seated, the rigging equipment is removed, and the load position is carefully checked and adjusted. Securing the locomotive is a critical phase of the operation. Heavy-duty chains, binders, and locking mechanisms are applied at multiple points to restrain forward, backward, and lateral movement. Each tie-down is tensioned and inspected to meet transport safety regulations. Additional padding and protective measures are used to minimize vibration and prevent cosmetic damage during the journey. With the load secured, the tractor unit is connected to the trailer, forming a long and powerful transport combination. Final safety checks are carried out, including brake systems, suspension alignment, lighting, and load stability. Route documentation and permits are confirmed, as the convoy must follow a pre-approved path suitable for heavy and oversized loads. The journey from Edmonton to Stettler requires controlled speeds and careful maneuvering, especially when navigating intersections, curves, and changes in road elevation. Escort vehicles may be used to manage traffic and ensure public safety along the route. Every kilometer of the journey reflects the planning and expertise involved in transporting such a unique piece of machinery. Upon arrival in Stettler, the locomotive will be unloaded and prepared for display and operation at the Rails and Tails Steam Festival. Its presence supports the celebration of Canada's 150th anniversary, offering visitors a tangible connection to the country's railway history. The successful transport of locomotive No. 1392 demonstrates how modern heavy haul techniques can preserve and showcase historic engineering for future generations. A serious accident involving an offshore Liebherr crane at the Rostock overseas port. The incident occurred on Saturday afternoon during a heavy lifting test operation. According to police reports, the crane was mounted on the vessel Orion and was lifting a 500-ton pontoon positioned in the water alongside the ship. During the lift, the crane hook suddenly failed and broke, most likely due to a material defect identified in the initial investigation. As a result, the crane's almost vertical boom violently jerked backward, striking both the ship and the edge of the quay. Authorities estimate the total damage to be between 50 and 100 million euros, although Liebherr stated that an exact figure cannot yet be confirmed. "12 people were injured in the accident, most of them suffering only minor injuries. At the moment of failure, the crane was under extreme mechanical tension.